That's where we find our Morgan Brennan, who joins us today from Hawthorne, California.
Joining me now, Dave Limp, the CEO of Blue Origin. Joining me now, Jared Isaacman,
Peter Beck, founder and CEO of Rocket Lab.
So joining us now is Trimble president and CEO Rob Painter. Trimble, a software, hardware, and services company in the construction and agriculture space. Chad, congratulations on 10 years. That's pretty incredible. And Rob Painter, CEO of Trimble.
Good morning.
It's good to be back with you.
Hey, thank you. Good to be here in New York.
So both of those videos, I think, were a good kind of precursor to the conversation we're about to have here today. But maybe we just start, nonetheless, maybe we just start with a little bit about Trimble and the space, no pun intended, in which you play, since you are the OG in the space economy and you have been able to harness the technology of GPS for almost 50 years now.
So there's the origin story of Trimble goes back to 1978 and Charlie Trimble, who was on the video, which, by the way, I want a copy of that video, Chad. It's really, it was terrific work. I'm actually only the third CEO in the company's 47-year history. So we can probably come to the origin story of Trimble. That's probably a whole separate topic in the development of the company through time. You know, we're a company that would be the application layer, let's say, in the stack of space technology. Many of you work in, I would call it the infrastructure layer or the delivery layer who are here, and we think of ourselves as that application layer. So turning the data and the signals that come from space into actionable intelligence in the real world. These days mostly applied in surveying and mapping and engineering and construction and transportation and logistics. We're a NASDAQ listed company in the S&P 500 today, so kind of reflecting on 47 years of history from a startup in a garage in Silicon Valley to being in the S&P 500 does say something about the significance of the technology and the space.
Yeah. And so let's talk a little bit about that application layer, as you put it, because I think what's so fascinating about this, and it goes back to what that video just told us, and that is this idea that space infrastructure and technology from space is the building blocks for innovation here on Earth, and you're very much at the forefront of that.
So would you like to go into the actual applications?
Yeah.
Okay, so let's talk about transportation, because I see one of my colleagues here runs our transportation business. You know, the idea of years ago of dot on a map was a very novel application. How to create precise maps was a novel application. You know, today that becomes table stakes for doing business. If you're a trucking company, you face at the moment, actually, you face a freight recession, and you face challenges of optimizing your networks. You know, how do you make your vehicles work? How are they staying literally in motion? How do you eliminate deadhead travel? If you're a trucking company, you have almost 100% turnover of your drivers every year. Imagine all of you in your respective businesses. If you lost your entire workforce every year, that's the business of trucking. So we start with the positional element. I call that the where of Trimble meets the what and the why, and the what becomes the modeling around that, the software content around that. In a construction environment, 80% of projects are late, 40% are over budget. And I can usually in a room like this ask people, how many of you have ever done a construction project? You know, most hands go up, and then I would say, okay, keep your hands up if your job was delivered on time and on budget. Very few hands ever will stay up. Like, we can viscerally appreciate the complexity of this industry. By applying geospatial intelligence, so highly accurate position meets highly accurate design and engineering models, meets the business systems as back office systems. We've been transforming the way that construction works. And then I'll finish with agriculture example. In the world of agriculture, Trimble invented the precision ag business. And there's an origin story there through the development of GPS or GNSS technologies over time to enable that. If you're a farmer, what are you trying to do? You're trying to optimize your yield, and you're trying to minimize the inputs. That's revenue minus cost equals the profit that a farmer can make. Through putting the seed in the exact right place it belongs, so think centimeter level accuracy, you optimize the yield of the crop because they're not too far apart and they're not too close where they compete for the nutrients. And then if you have a digital map of the farm, you know the stronger part of the soil, the weaker part of the soil, and so you can variably rate apply an herbicide, a pesticide to that, bringing down not only the environmental impact, but the cost of that application while increasing the yield. And it starts, though, with this idea of position at the core of that as the basis.
So let's go back to the origin then, and the fact that Trimble was able to start with this technology that at the time was very new, only government operated and controlled, and when it was unlocked for commercial applications, Trimble was right there ready to go and be able to start to build out these application layers. So
it's a fascinating, to me anyway, it's a fascinating origin story of Trimble, and actually really the origin, the pre-origin, maybe the prequel to Trimble starts in 1957 with Sputnik. And as Sputnik went up here on Earth, we were able to figure out that you could, by tracking those, that you could reverse engineer that, or if you did the inverse of that, you could know the position. That led in the 60s to an early prototype called Transit. And then in I think it was 73, the idea was born to start a GPS program. The first satellite went up in 1978. Trimble was founded in 1978. And the origin story of actually Trimble being founded is Charlie Trimble worked at HP, and HP had worked on a technology called Loran sea positioning. And if some of you have marine backgrounds, you might know of Loran. HP wasn't interested in the Loran technology, and so Charlie bought it, the know-how and some IP from HP to start Trimble. A couple years later, he bought a breadboard for a technology that some of you might have heard of that HP wasn't interested in. That technology was called GPS. So think about that for a moment. So now you're in 1978, fast forward a couple of years into like an 82, 83 timeframe, actually 84 timeframe, we have 7 satellites that were available at that time. And as we know, the GPS constellation has about 31 satellites. If you superset that to GNSS, there's over 100 satellites today. At the time when there were 7 satellites, and there's a lot of engineers in the room, you can appreciate that the geometry you could derive off of that was actually very limited. So the business model at that time would have been to oil and gas as an end market, because who's going to be able to pay for that? A receiver in 1984 cost $100,000. And you could only see the satellites about 3 or 4 hours a day, and you would collect the data and you'd have to post-process it overnight or many nights to actually get the actionable intelligence off of that. So very limited market in those days. Fast forward a few years, there's more satellites available. We took a big bet in that call it late 80s timeframe to start doing long baseline surveying, as well as deformation monitoring for earthquakes with the Japanese government. At the time was a big move for us. You fast forward again to 1992, and Trimble invented RTK positioning, real-time kinematic, and that moved from doing post-processing to get highly accurate data to real-time data. And to do that, you're correcting for errors in the ionosphere and the troposphere to triangulate to highly accurate position. So we don't think about good enough position at Trimble. We think about, industrial grade positioning is going to need to be centimeter, call it sub-centimeter level accuracy to do the kind of applications that we're doing out in the real world. And at the time then when RTK is invented, you fast forward a few years again, and once you have the ability to do highly accurate positioning in real time, that opened up the idea to do guidance and automation, which led to the invention of precision ag, and then same thing in construction. So precision construction, digital construction, whatever you might want to call that. So a rich history of positioning technologies. That would be on the GPS and then GNSS side of the house of Trimble. Met laser and optical positioning as this foundation of the wear. And then where we took the company kind of starting in the 2000s was backing up and thinking about the position as a sensor, the receiver as a sensor, and redefining the business that we were in. Once you think about, you start asking yourself the question, what are you doing with that location? Why do you want that location? You're in a totally different frame of mind of how you think about your business and how you think about the industry. And so we started thinking more about the vertical markets the end markets that we were serving, and we started thinking about how we could build workflow capabilities. Like you're creating a position to do something else. Okay, what's that something else that we could do upstream or downstream, which then set off the next wave into the 2000s. I'll stop there.
So really IoT is what we're talking about right
Industrial
now.
IoT, yeah.
Transportation, agriculture, oil and gas. You're in a number of end markets. I guess which one is growing the fastest right now? And where do you see opportunities emerging now in the 2020s that didn't exist before?
So the largest end market we serve today is in the engineering and construction realm. It's engineering and construction we see as about a $50 billion addressable market. It's a large market that's global, it's underserved, it's underpenetrated, fundamental problems in terms of productivity, quality, safety, transparency, and environmental sustainability. So this built environment, whether it's our physical infrastructure or linear or horizontal infrastructure or the vertical construction as well. So very large market. We have an ability with this, if you actually think about a surveyor and you think about the life cycle of construction, we think about it from the plan to the design to the build to the operational phase. And on the other axis, if you think about who the participants are in construction, you have architects, you have engineers, you have construction companies, you have owners. And if you start in that plan phase of construction, really it's a feasibility study, you have a surveyor. And the surveyor gets to a lot of the origin story of Trimble serving surveyors. Well, what does a surveyor do? A surveyor creates a digital model of the physical earth. And that then begins a next workflow after that to move from that digital model into, in this case, you could go into agriculture or oil and gas, but let's talk about construction and where we go with that. You then need to make a design model off of that, a highly accurate design model. So if we're in a building like we are in today, you know, the Trimble software modeling, engineering modeling, we work in steel, concrete, mechanical, electrical, plumbing applications, where you design down to the level of the anchor bolt accuracy. So it's not just a pretty picture representing the design of the building, it's actually highly accurate models. And so a company that thinks in terms of centimeter level positioning, not a surprise, will think in terms of highly accurate modeling and how we can map the digital world to the physical world. When you do modeling at this level of precision, you can eliminate the rework before it actually happens. Because often you have these, right? It's a very fragmented industry of subcontractors, and the mechanical contractor is different than the electrical, it's different than the plumber, and often this is what makes construction late and over budget, is they have conflicts out in the field that they have to resolve out in the field, and then you have to rework things. Well, if you can eliminate the rework before it actually happens, you can drive precision into the whole process. And these days we connect it to back office, ERP systems, project management systems, estimating systems, all of this idea of a highly accurate model that becomes more and more context-rich throughout the operational life cycle. And you can take that model and then you can bring it back into from that digital world or the office, you can bring it out to the field again. So you're starting to round trip. And then with Trimble surveying technology, we've got layout technology, you can ensure that you're putting that digital design, that you're actually putting every element in this building. There'd be millions of points in this building that are highly precisely placed. And by applying that digital model and taking it into Trimble physical survey equipment, you're putting it in the exact place where it belongs, and you can drive about a 10x productivity improvement through that construction process.
10x. Mm-hmm. Sounds like a great foundation for AI.
Yes. Okay, well, we're 15 minutes in. It's the first time we've said AI.
I'm pacing myself. I know we have 35 minutes together. So.
Exactly. Let me even back up like at an R&D perspective at Trimble. We spend about $600 million a year in research and development. And now I map that to the possibilities in AI, and I tend to think that the AI is going to correlate highly to the quality of the data that supports that, and the scope and the scale of that data. And in construction, actually, of an overall Trimble context beyond construction, today we manage over $1 trillion of construction through Trimble systems. We manage tens of billions of dollars of freight through Trimble today. We have millions of customers, users of our software, and hundreds of thousands of instruments and machines in the real physical world operate on Trimble. That's a unique corpus of data. And so I think about possibilities as a vertical LLM. Like, we're not going to be the LLM provider, and just as we're not going to be the satellite provider, we think about being the application layer, a very domain-focused and domain-centric application layer. So there's a unique set of data that we think we can move customers from optimizing tasks to optimizing systems. And I don't hear those exact words from our customers today, so I'm paraphrasing. What I hear is I hear them talking about solving their higher order problems. We've unlocked a lot of task productivity through point solutions, individual solutions. The idea is how can we unlock the system, optimize the entire system. And we see that through the connection of the stakeholders, connecting the data. And as you're doing that, you can get some really interesting AI derivatives that come from that. You can get applying AI to what we're doing in the positioning world today. You know, one of the things, if you're in an environment like here in the cities, you have it's called multi-path, which is to say that you have the buildings occluding the signals, and it makes it harder. Or if you're under a tree and you have canopy, it makes it harder to reach that. And we can apply AI to how we're receiving those signals today to do a predictive indicator of where that satellite should be to correct for errors. We can overlay inertial technologies, visual technologies as well, to have redundancy in the sensors. More data, more possibilities for AI to produce a better outcome. And then that, to me, is a subset of that superset of thinking about the industry life cycle continuum and applying AI for those differential outcomes. So when we think about AI at Trimble today, I worked in consulting like 30 years ago, and I never lost the 2x2 framework. 2x2 can solve everything. And on our 2x2 that we think about by applying AI, on one axis we think about the internal uses of the technology, and on the other axis, external, so think customer facing. Or let's just on the x-axis. On the y-axis, we'll think about productivity outcomes that we aim for with the use of the technology, and revenue facing activities. The one that's the most fun to talk about would be any time it's more customer facing and revenue creates revenue opportunities by producing better outcomes. But I tell you, we're getting, as you can imagine, and probably many of you are, I really like what I'm seeing in terms of the internal productivity that we're getting out of the use of the tools today.
One of the things that's fascinating to me is that over the course, since 1970, you just sort of laid out the time frame and each kind of key stage for the company, but you've also acquired 150 companies along the way and built out your portfolio. So how do you think about what you're going to build internally versus what you're going to acquire? And perhaps just as importantly, how do you maintain the culture of that company and continue to innovate even as you are acquiring all these companies?
Yeah, it's a terrific question, and I actually I've got 3 Trimble colleagues up here in the front. All 3 came through acquisition into Trimble, so I think we've done okay on that. 150 acquisitions is a lot. Got a lot of lessons learned, good lessons and bad lessons, I'll admit on that one. I could talk about this one for forever. We don't acquire for the sake of acquiring. It's in pursuit of the strategy. And so our vision is we have a mission at Trimble to transform the way the world works, a vision to deliver products and services that connect the physical and digital worlds. We want to connect construction. We call it connected construction, connected forestry, connected supply chain, connected utilities. And when you start thinking in that redefinition of what business that we're in, and you want to serve those architects, engineers, contractors, and owners throughout the project lifecycle, you have a choice. Are you going to build that organically, or are you going to do that inorganically? Now, we've done both, thus the $600 million a year going back into research and development. And we've put our balance sheet to work definitively many times over the years. And the calculus generally is around the speed of development, the speed of getting to market, meets the quality of the asset, the capability, meets the geography of that. So we're a global business. We're doing business in over 175 countries. So we think global, and that often will take us to a given market, a calculus of how quickly could we get there on our own, how established is it. Sometimes there's the acquihire, the acquisition for talent and IP and capabilities. Historically, we've had an acquisition philosophy that has retained a lot of the principles, the leaders of the companies that we had acquired. And I actually have literally 3 examples. Now that I'm looking at you guys, 3 examples of that in front of me, 3 leaders of organizations that came into Trimble. We tend to do well with people who are mission-driven, who want to go see transformation happen in an industry. I tend to think that on the sell side, when you acquire a leadership team, our leadership team comes in through acquisition, you have transactors and you have builders. We do well with builders. Builders tend to stay after acquisition. That to me speaks to the culture and the opportunities that we have. The transactors don't tend to stay as long. The transactor being the person who's in there just for the deal, to get the deal done, and that might correlate sometimes when we have acquired from private equity as opposed to something that's more family owned.
You just mentioned good lessons, bad lessons. I'm gonna pick at that. One more quick question on that,
Sure.
In part because we do have, I do know we have some founders in the room who are probably thinking about growing their companies too. What are some of the hard lessons that have been learned?
Oh, there's so many lessons. So actually, I can weave the good and the bad together. Luckily, there's been a lot more goods than bads. In fact, I think if you don't have any bads, any tough lessons learned, then you're not trying hard enough. You got to take some risks, and every now and then you fail. At a different scale. Chad and his team at Space Capital, right? This is the business of being a VC. Is the stark and harsh reality is that most companies won't make it, and then you've got a few that really will eventually break through. So we think deeply about companies that know what problem they're trying to solve, like have a real focus on that, who are very committed to the outcome, like the destination, but flexible in terms of how they get there. It's like when the winds change, are you able to pivot the sails to head towards that direction? Some people aren't, like there's one way and there's only one way to get there. That can be a little rough. Some companies, and this may be a little bit more in the software world, where today actually Trimble is transformed into 3/4 of a software company. There's a whole transformation we've done of our own business as well over the last few years. Sometimes if we've acquired a company that's very sales driven, you might think that's a good thing, and it's not necessarily a bad thing. The problem if you're too sales driven is you're saying yes to every customer, and you can really start to Frankenstein a code base. And so I think say flipping this around to founders in the room is stick to building capabilities that scale. Resist that temptation to keep forking code to chase that next customer and not ever actually bringing coherence to that, because there's 2 words that'll just nail you in a long term if you don't get it right, and those 2 words are sustaining engineering. In the short term, it's easy to convince yourself why something might make sense to do, that branch or that fork of that code. And if you're too open, too flexible to that, you really get caught eventually with a lot of technical debt that you have to overcome. I would also go in a totally different direction. I think about partnerships. I think about policy. I think about go-to-market. So sort of 3 things to think about on a policy perspective. Trimble's had to make a few big policy bets along the way, like so there's an aspect of staying in the game, and I really think about, given the room and what you all are doing. So let's say take the GPS spectrum. We believe emphatically that we have to protect the spectrum, and there's been threats to that spectrum here in the last few years, and we've stepped up and put our time and people and money to work to protect the spectrum. If we lose the integrity of the spectrum, we're all going to suffer from that. And so, stay engaged in the world that we're in. I think you have to stay engaged in policy and be an advocate for good policy. If I think about partnership, For a company of our size, I think we are pretty unique with respect to some of the joint ventures we have. So we have 4 joint ventures. We have a joint venture with Caterpillar in machine control and guidance and construction. We have a joint venture with Hilti in building and construction, bringing positioning to tools. We have a joint venture with Nikon in the surveying business and as our path to market in Japan. And now we have a joint venture with AGCO in the precision ag business. So we've been open to partnership. In the early days of Trimble, we had the technology, but we didn't have the brand. We didn't have the path to market. And that led to a joint venture the first one that we established with Caterpillar, who brought that brand and that street cred, met the technology cred, made a really good partnership for us. And then I'll finish with go-to-market. It's one thing, we're the application company. It's one thing to develop the technology, but you equally have to bring the technology meets you call the technology and the product meets the go-to-market. And I know many of you in the room will appreciate what I'm saying. It's one thing to get those first few customers, to get that first 5 or 10 million of revenue. To go global is an entirely different proposition. It's taken us decades to build up the capabilities to go to over 175 countries. In our hardware businesses, we sell through dealer partners around the world. And through our software businesses, we primarily sell direct. So really, really consider the go-to-market aspects of your business. That's often the hardest part for folks to overcome as you scale businesses, is reaching those inflection points that break you through to do business at a higher level. And we've certainly had our lessons and luck along the way, and a lot of hard work to make that possible.
I'm going back to policy, especially since you are a global company. My phone's been sitting, I brought my phones up on stage. I probably shouldn't have done that. They've been blowing up. I'm getting all the push alerts from CNBC and everywhere else because the market's ripping and, there's a pause and a lowering. They're not going away, but a lowering of some tariffs between China and the US. So the trade policy piece of this, how are you navigating that?
Yeah, so at a principled level, we stand for free and fair trade. And I'll be clear with the 2 words. I said free and fair trade. So our position is very much as a multinational technology company that we stand for the movement of goods and people, by the way, right? Immigration policy is important for us to have the best talent available to access at the company. As again, many of you, and I just from meeting folks last night, there's people who are here in the US who come from all over the world. Just absolutely fascinating life stories of how so many of you are here today. That has been such a special part of this country and the development of the technology space, and we can't lose that. So, huge believer in immigration, sensible immigration. On the trade perspective, we separate the digital and the physical. We're certainly attributing the trade conversations to the physical side. So if you take the physical side of Trimble, we have a global supply chain. Everywhere from Mexico, actually probably mostly comes from Mexico, Canada, and Central to Northern Europe, Western Europe as well, is where the majority of our stuff comes. Minority coming from, very little actually these days comes from China. It's absolutely complicated place, as you can all imagine and appreciate, because I'm sure many of you, maybe all of you, have your own version of working through the tariffs and what they mean to your own cost of goods sold. So it's a bit of a minefield to wade through this. What we do is, we've said, let's control what we can control. Let's be clear about the principles upon which we stand, and in that control what we can control. I don't have time to lose a lot of sleep about what might be happening in trade this hour, this day, although I am happy for if it's green, which I suspect it's pretty green
It's pretty green.
It's pretty green. How's Trimble doing this morning? You have to tell me.
Last I checked, pretty well.
Okay. Okay. So up 5%, I'm told. So maybe we should stop talking. Let's just go with that and call it a day. But I really do believe you got to stay engaged. So we spend time when we can on the Hill, advocating But advocating, I'd also say in a principled manner, not to make it too personal or too emotional. That backfires.
The other piece of this is a geopolitical one, and we've seen it. We've seen it in the last couple of years. What happens with not just government space infrastructure, but also commercial space infrastructure. In times of conflicts, look no further than Ukraine, Russia, what happened with Russia when they started to invade Ukraine. You don't have the infrastructure, you don't own the infrastructure, you're not a satellite operator, but you're dependent on the data that's coming from that infrastructure. So how do you think about navigating that? How do you think about what needs to happen for things like anti-spoofing and building beyond GPS and resilient space architecture and everything else that's getting discussed and sort of money getting thrown at right now?
Yeah, it's a terrific question. And luckily, some of you in the room are part of making that happen. So if you want to go in the low Earth orbiting satellite direction, and where can we get redundancy off of those satellites? We do work with the Army Corps of Engineers in GPS denied environments. How could you still get a highly accurate position? We think about sensor fusion. So that goes back to inertials and known points. If you can have known points and then triangulate off of that. So there's a sensor redundancy. Spoofing and jamming are a big deal. Chad had that in the video. There was some years ago at Newark Airport where a truck driver didn't want to be tracked, jammed the signal off the GPS on the vehicle and took down the Newark airport. You see this in Europe when Putin is moving around, let's say the Black Sea, suddenly somewhere in Eastern Europe is showing as if it's in Western Europe. Like, these are real threats. Like, this isn't make-believe. Like, this really is happening. And one thing that's kind of cool talking to this audience is you actually know what I'm talking about. If we're talking about, I don't even have to just keep saying GPS. I can say GNSS, and most of you will know that that's the superset. And you know that the signal's a whisper, a really light whisper, the strength of that signal, thus the vulnerability that it has, thus the redundancy that some of you in the room, I think, are able to bring to that. So we think about how we can work with some of the folks in the room, and obviously some who are not in the room, with additional signals. If you were actually to go after, let's say, the GPS constellation, we work with GNSS, so we can track multiple satellites. If there really was a total threat and satellites start getting shot down, whenever I get asked about this by investors, I think we got a lot bigger problem coming than little old Trimble if these things were to start coming down. So I think less about the scenario of satellites getting shot down, and I think more about them getting compromised, spoofed, and jammed.
Whether it's from a space infrastructure standpoint or space economy standpoint, or just even what that's enabling from a software and innovation standpoint, what are you most excited about in terms of technology and where we're headed? Because not only are you building stuff inside the company, not only are you acquiring companies, you also invest through a venture arm as well.
Right.
You look across this emerging, for lack of a better term, space economy. What excites you?
Yeah, so put me in the, consider your source here, but put me in the techno-optimist category. There's this, it was a Justin Trudeau quote, the pace of change has never been this fast, and it will never be this slow again. So we live in extraordinary times. We have extraordinarily privilege to get all of us to get to do what we get to do. I'm so thrilled to be able to serve markets. We're like the dirty boots on the ground. We're a physical AI layer out in the world. We're making, I think Trimble makes a positive impact in the world. And we say build the world, move the world, feed the world. This is work you can feel good about doing. Through the work that we're doing, right? We optimize yield of crop. We're helping move the goods of commerce. We're literally a part of building our infrastructure that each one of you experienced Trimble in some form today as you got here. You just didn't know it, much like those signals that we don't actually see coming down from space. It's ubiquitous. We're ubiquitous, and I'm so excited to be a part of that. And I think about the application of technology and where we go as we get more connected. and as we can drive more collaboration in the industry, and yes, as we can have more data and more AI, it's going to transform how we work so that we can enable transformation to happen in the world and the industries that we serve.
We have half a minute left, so just any final comments or thoughts or anything we haven't gotten to that you want to note before we get off stage?
Hey, I want to just thank everyone who's here. I want to thank you all, Chad and team, for putting this conference together. Morgan for coming to be with us this morning and doing this. You know, she covers the space of space, as we know. So to have good advocates like Morgan is a good thing to create awareness for all of us. And thank you all for what you do. Keep doing it.
All right. Look at that. Right on time. Rob Painter, CEO of Trimble. Thank you so much.